spot them separately, or you can just put them together. Now, here's what I would recommend. This problem number, or letter E here, is initially written as two separate things. I would think about this, and you don't have to rewrite it, but you can also think about this as being negative 375 over 3, because they're both under a cube root. All right, what I would do first, just see if you can reduce that or divide that. You guys don't need your laptops right now, so let's put those away. Thank you very much. All right, so I'm just literally going to take my calculator. I'm doing negative 325 divided by 3. Now, I did the wrong number, fired. Okay, negative 375 divided by 3, which ends up actually being a nice number. So that actually gets rid of the fraction. So this is really the cube root of negative 125. Now, this is actually a perfect cube root. Does anybody know what this one is? It's 5. Okay, now all you have to do, if it's got a little negative, totally fine to do under an odd root. The answer would just be negative 5. The reason, if you do negative 5 to the third power, that's negative 125. So if you take the cube root of negative 125, the answer is just going to be negative 5. And if you guys were not, you're like, I didn't know that, you could break it down with the factor tree. It's just everything would cancel out. Or if you want to notice that third column, 125 is on that list. And if you just back it up to the left side, that should be the root. So 125 cube root is 5. If it's got a negative, you just put a negative in front of it. Okay, now kind of the same argument. I would just try this before you do the problem. See if, I'm going to rewrite that as a fraction just all under a square root. You can think about it separately or together. You don't have to rewrite it. But I just want to see if that reduces. So I'm just going to use my calculator to do that because I'm trying to save some time. So just do 27,243, hit equals, and then if you hit that math, enter, enter, it'll convert it for you. So I'm not taking a square root, I just reduced that fraction. This is really the square root of 1/9. Now, if I do that, that makes the problem way easier to do. What would the square root of 1 be? 1. What would the square root of 9 be? 3. Done. That's the answer, 1/3. Looks way more complicated when I started it, but if you simplify first, it usually will save you some time. All right, now the last two down here at the bottom, these are going to involve some variables. So again, you do not have to rewrite this. I have to because it's my brain. All right, so this is the same as cube root 3m to the 8th over 192mn to the 3rd. So first thing I would try to do is see if that fraction, just work with the numbers for a second, see if 3 over 192 reduces. And I'm probably doing a bad example by using my calculator for all this, but why not? You got your tools, you should use them. Okay, so 3 over 192 is really 1 over 64. I'm just going to put the 64 in the bottom. We can put the 1 in the top if everything else cancels out, but I don't think we're going to need it for this problem. So just ignore the cube root for a second. I'm just looking at that fraction to see if we can simplify it. So do you see I have m to the 8 on the top, and I just have m, no exponent, so that's technically to the first power in the bottom. So just using exponent properties, where do you have more m's, the top or the bottom? How many more? 7. Okay, so really that would simplify the top to be m to the 7th. Okay, now there's no n's on the top at all, so nothing's going to cancel there. So I'll just leave n to the 3rd on the bottom. Now, I did not take a cube root. All we were working on there was simplifying. And so the bottom of this is actually a perfect cube root. If you look at your lovely little list under the 3rd column, 64 is the 4th one down. So the 4th root there is 4. And then for the variables, you just take the exponent and divide it by the index of the root. So 3 divided by 3, that's just going to come out as just n to the 1st. I would just write an n. You don't have to write an exponent. Okay, now, sorry, the top is a little bit more annoying. So 7 is not divisible by 3, but I could get a number leading up to 7 that would be divisible by 3. So we haven't done this for a couple days. I would break that apart. Biggest number out of 7 that you could get 3 to go into to break this apart. Remember, the exponents would add back together. I would rewrite that as m to the 6th times, just m or m to the 1st if you want to do that. Now, under a cube root, I can remove any perfect cubes. So that's why I picked 6 to be my exponent, because that was the biggest number I could get out of 7 that would be divisible by 3. That first little piece there, we can remove from the cube root it would be m squared. So 6 divided by 3. So on the top of the fraction here, we'd have an m squared, and then still under the cube root, we would just have this 1m left over. So it looks a little garbagey, but that is going to be my answer for that question. So if you've got something under a cube root, it's totally fine to have a root in the top of the fraction. It's not okay to have a radical of any kind in the bottom. We're going to spend a whole day on that in the next couple of days. I don't remember exactly what lesson, but we're going to do rationalizing denominators. You should not run into that on any of the homework problems today. Okay, and I got one more. So I'm going to put these guys together. They're both under a fourth root. So this is really the same as 1024 x to the 15th over just a 4x. So I'm just grabbing my calculator, just deal with the numbers. So I'm taking 1024 divided by 4. It's a nice number. So I got 256. Where do you have x, more x's, the top or the bottom on that one? How many more? 14. So this 1 on the bottom is going to cancel 1 on the top. Actually, what happens there, if you simplify that, you don't even have a fraction anymore. So this is the fourth root of x to the 14th. Now, or 256, x to the 14th, forgive. Now, if you look at the lovely fourth column here, 256 is on this list. So all the way back to the left would be the root. So this is actually just going to come out as a 4. That's 4 to the 4th power. Now, with the x to the 14th, 14 is not divisible by 4. So I'm just going to do this kind of to the side just with the variable. I'd break that apart. Out of 14, what's like the biggest number I could get out of 14 that 4 would go into? 12. So just when you break these apart, it should be that if I add them back together, I'm just using the exponent properties, it should add back up to 14. So when we pull the 12 to the side, we'd have 2 left. Then we're just going to remove 12 divided by 4 would be our perfect fourth root. So we pull out an x to the 3rd. So I pulled out 4 from the 256, x cubed, and then this x squared 2, we can't divide that by 4, so that's going to be stuck under the fourth root. As long as your exponent is smaller than the index of your root, you can't simplify that any farther. Is anybody having a question?